Welcome to the fastest way to learn data structures and algorithms, with this premium revision material. Today, we are mastering LeetCode 121, the best time to buy and sell stock challenge. This is a fundamental problem that tests your ability to think greedily and optimize for a single pass. It is a favorite for initial interview rounds at companies like Google, Meta, and Amazon. Let us look at the problem statement. Imagine you are given an array called prices, where each element represents the stock price on a specific day. Your goal is to maximize your profit by choosing one day to buy the stock and a different day in the future to sell it. If no profit is possible, for example, if the price only goes down, you must return 0. Keep in mind the core constraint: you must buy before you can sell. You cannot look back in time to buy a stock after you have seen a high price. Think of this like a hike through a mountain range. To make the most money, you want to buy at the lowest valley and sell at the highest peak that comes after it. Our analogy is simple: the lowest valley and highest peak. We will keep a constant eye on the lowest price we have seen so far, and at every new step, we will check how much profit we would make if we sold right now. Our strategy follows a golden rule: we track the minimum price as we scan, and calculate the potential profit at every step. We use a greedy approach with a single pass, meaning we only look at each price once. This ensures our algorithm is extremely efficient. We maintain two variables: min price, initialized to infinity, and max profit, initialized to 0. Now, let us dive into the dry run. This is the most important part. Look at our prices array on the screen: 7, 1, 5, 3, 6, and 4. Notice the variable tracker box on the right. It will track our min price and max profit as we move along. We initialize min price to infinity and max profit to 0. We start at the first day, where the price is 7. Since 7 is less than infinity, we update our min price to 7. Our max profit remains 0 because we cannot sell on the same day we buy. Moving to the next day, the price is 1. Look at the tracker: 1 is definitely less than 7, so we have found a new lowest valley. We update min price to 1. Max profit is still 0. On the third day, the price is 5. 5 is not less than our min price of 1, so we do not update the minimum. Instead, we check the profit. 5 minus our minimum of 1 gives us a profit of 4. Since 4 is greater than our current max profit of 0, we update max profit to 4. Next, we see a price of 3. 3 is not less than 1, and the profit, 3 minus 1, is only 2. Since 2 is less than our current max profit of 4, nothing changes in our tracker. On the fifth day, the price jumps to 6. 6 is not less than 1, but look at the profit. 6 minus 1 is 5. This is better than our previous best of 4, so we update max profit to 5 in the tracker. Finally, we encounter a price of 4. 4 is not less than 1, and the profit of 3 does not beat our current best. We have finished our scan. The variable tracker shows our final max profit is 5. Now that we have walked through the logic visually, let us see how these variables translate into our Python code. We define our function max profit, which takes the prices array. We initialize min price using float infinity and max profit to 0. We then enter a single loop that iterates through every price. If the current price is less than our min price, we update the minimum. Otherwise, we check if the difference between the current price and our min price gives us a new best profit. Finally, we return the max profit. This approach is elegant because it only requires one pass through the data, giving us a time complexity of O of n, and since we only store two variables, the space complexity is a perfect O of 1. And that is the best time to buy and sell stock challenge mastered. Save this video for your next interview revision, and follow for more deep dive DSA explainers. Send this to your coding partner to help them level up.